Hello everyone, welcome to SAT Maths. This is chapter number 3, Functions and Equations, and the first subtopic is Relation and Function. This is the part 1 for the chapter number 3. So, in this relation and function, first of all we have to understand about the coordinate plane. What is a coordinate plane over here? So when we say a coordinate plane, it is formed by a horizontal line called the x-axis and a vertical line called the y-axis, just like these. This is the horizontal line, this is x-axis, the vertical line, this is the y-axis. These lines meet at the origin. So over here, the origin, the coordinate of origin is 0, 0 over here. And the axis divides the plane into 4 quadrants. When we draw this axis, on the right side it is x, on the left side it is x dash, on the y, and this is y dash. On the right side it is positive, like 1, 2, 3, 4, 5, 1, 2, 3, and here it is negative, negative 1, negative 2, negative 3. In the y also, upward is positive, 1, 2, 3, and in the downward it is negative. Now when we draw these two lines, you can see that it is getting divided into 4 quadrants. So this is called the first quadrant. In the anti-clockwise way, this is called the second quadrant, this is called the third quadrant, and this is called the fourth quadrant over here. So these are the 4 quadrants. Second thing, the ordered pair. So when we say ordered pair, it is giving us the coordinates of any particular point, or you can say location of a point on a coordinate plane. Just like if you want to take any point 2, 1. So 2, 1 is the point over here in the first quadrant. It means the first coordinate is always represent the x and second always represents the y. So in the x we have to go 2 units and in the y we have to go 1 unit. So 2 unit in the x and 1 unit in the y. So that is 2, 1. In the same way, if you have to go minus 2, 2, so first we have to go in the x we have to go minus 2 units like on the left side, and then we have to go 2 units above. So we are reaching at this minus 2, 2. Similarly, minus 4, 4 is lying in the third quadrant because x is negative and y is negative. So we are going in this direction up to minus 4 and then downward minus 4. So we are reaching at this point. Similarly, 3, minus 2, 3 on the right side and 2 on the downward side. So basically what happens over here is, in the first quadrant, both x is positive and y is positive. In the second quadrant, what happens is x is negative but y is positive. In the third quadrant, both x and y are negative, and in the fourth quadrant, x is positive but y is negative. That is how we can plot any particular point on the coordinate plane. So if I say minus 5, 4 is lying in which quadrant? So x is negative and y is positive, so it means it is going in the second quadrant. Now, next subtopic over here is the relation. Now, what is a relation? It is just a set of ordered pair. So, whenever we write like this, something like this, 2, 3, 5, 6, 7, 9, in the curly bracket if I write, so this is known as the relation. It is just a set of ordered pair over here, 2, 3, 5, 6, 7, 9, like this. 3 ordered pairs are there in this. Now, there are different ways to represent the relation also. First way, it can be shown using a graph, a table, or a mapping. So here, when we say the graph, in the form of the graph, suppose if I want to write, or you can say this is the form of the table, the minus 3, 2, 1, minus 1, and 2, 3. In the mapping means the first element are written in one circle and the second set of element are written in the second circle. So minus 3 with the arrow diagram when we draw, this is known as the mapping. So minus 3 to 2, 1 to minus 1, and 2 to 3. If you want to write the same in the ordered pair, we can write the same thing in the ordered pair as minus 3, 2, 1, minus 1, and 2, 3. And if you want to represent the same thing in the case of the graph, so in the graph it's just like this in the coordinate system. So first coordinate is minus 3, 2. So minus 3 is over here, 2 is over here in the second quadrant. Minus 3, 2 this. Then 1, minus 1, x positive, y negative. So 1, minus 1 is over here. And 2, 3, 2 over here and 3 over here. So 2, 3. So that is how you can represent in the graph also. So these are the 3 ways to represent any relation, basically a set of ordered pair. Now, which relation is a function? That is the most important thing. A function is a special type of relation. Each input has exactly one output. What does that mean? Suppose if I am drawing like this, x is generally called the input values and y is generally called the output values. Suppose if I am writing 1 to 3 and here it is 4, 5, 6. So in the mapping diagram, if I am drawing 1 to 4, so the input is 1, output is 4. Input is 2, output is 5. Input is 3, output is 6. So here every input over here is having a 1 output. So this relation is a function. On the other hand, if we draw the another graph, 1, 2, 3, 4, 5, let's say. If I draw like this, so here you can see the input of 1 is having two different output, 4 and 5. 1 is related to 4 as well as 1 is related to 5. So we will say this is not a function. So whenever a single input is giving two different output, that is not considered to be a function. But two different input can give the same output. Like 1 to 3, if it is like this, 1 to 4, 2 to 4, 3 to 4, this is a function. It is a function over here. Different input can give the same output, but same input cannot give the different output. And when we say the set of all x coordinate, the input value, that is denoted by the domain, and the range is the set of all y coordinate in the relation. So if we are talking about this relation, so 2, 5 and 7 are the domain, 3, 6 and 9 are the range. Here also in this table, 2, minus 1 and 3 are the range, like this. So look at this. It is written the first question, express each relation below as a set of ordered pair and then determine whether it is a function or not. So if you want to write, let's say I'm denoting the relation by R, and if you want to write it in the ordered pair format, so minus 3 with 7, then next we have minus 1 with minus 2, then we have 0 with minus 2, and then we have 4 with minus 9. Now we will see, is there any input value which is giving two different output? So minus, since no x value is getting repeated over here, every input is giving the unique output, so it is a function. Similarly, it is written in the graphical form. So let's write in the ordered pair first of all. This point over here, this is 1 and this is also 1. So this is 1 comma 1. If you look at this second point over here on the second quadrant, 2 on the left and 3 above. So minus 2 comma 3, let's say this is A, let's say this is B, let's say this is C, and let's say this is D. If you talk about the point C, 2 unit left, 1 unit down, so minus 2 minus 1. And if you look at the point D, 3 unit right and 4 unit down, so 3 comma minus 4. So this is the relation. Now we have to see whether it is a function or not. So is there any value which is getting repeated? So you can see minus 2. Minus 2 is giving two outputs. It is giving 3 as well as it is giving minus 1. So we can say it is not a function at all. This is the mapping, the table format it is given. If I want to write in the form of ordered pair, 1 with minus 2, 2 with 3, 3 with 5 and 4 with minus 2. So here no x value is getting repeated over here. So no input is giving two different output. So yes, it is a function. This particular relation is a function. Now the next one is called the vertical line test. This is a method to check whether the graph of a function, graph of a relation is a function or not. So here the graph will be given to you and you just have to draw a vertical line and see whether the vertical line crosses the graph at more than one point or not. Suppose if I draw the graph of a parabola like this, I want to see whether this particular graph is a function or not, or it is only a relation. So just try to draw any vertical line. So if I draw a vertical line over here, you can see this vertical line is intersecting in the graph at only one point. So we will try to draw a line in such a way so that it can intersect the graph at more than one point. But right now you can see it is not. You can draw the line anywhere. If you draw over here, this line is also intersecting at one point. So you cannot draw any line which will intersect the graph at more than one point. So yes, it is a function, because we are not able to draw any line which intersect the graph at more than one point. But if you look at the graph like this, let's say if the graph is like this, now I want to see whether this is a function or not. So I will try to draw a line in such a way so that it should intersect at more than one point. So we will not draw anywhere, we will try to look where we can draw. So if you look at this in the middle region over here, if I draw the line over here like this, so you can see this line is intersecting the graph at 3 points, basically more than 1 point. So what does that indicate? It indicates that at this particular x value, we are having 3 different y value, y1, y2, y3. So we can say it is not a function. So you just have to draw a vertical line. If it is intersecting the graph at more than 1 point, it is not a function. This is known as the vertical line test. Now the next thing is the function values. Generally the questions comes in the exam in which we have to evaluate the function. So first of all, the notation, how to write the function. So it is saying equations that are functions can be written in the form that is called a function notation. In the function notation, suppose if I am writing y is equal to 5x plus 3 is the equation. If I want to write it in the function notation, I will be writing it like this: f of x is equal to 5x plus 3. So this fx and the y, always remember, the y and the fx are the one and the same thing. What does that mean? This f indicates the name of the function. We can use f, g, h, anything. This represents the input value, and this complete thing represents the output value. This x is the input, 5x plus 3 is the output. So if you give the any input, you can get particular output. Or you can also say this function works as a machine. Here, if you give the input of, let's say, 2, so this machine works on this 5x plus 3 principle. So 2 will get multiplied with the 5, which is 10, and 10 plus 3 is 13. So this 2 is the input value, and it is giving us the output value over here. And if you want to find the function value at a particular x value, so it is noted by C. Suppose if for the same function, if I want to find the value when the input is 2, I will be writing it like this: f of 2, that is equal to 13. It means if I am giving the input of 2, I am getting the output of 13. That is the notation for this function. So let's have some questions based upon this. So a function is given to us and it is asking us to evaluate at each value. So first part says evaluate when the input is minus 2. So you just have to replace x with the minus 2 and then solve it. So it is negative 6 plus 2, which is negative 4. Very easy. If you look at the B part, in the B part, it says when the input is c minus 2. So c minus 2 means you just have to replace x with the c minus 2. So if you replace x with the c minus 2, it is 3 times of c minus 2 plus 2. Use the distributive property, and it is 3c minus of 4. Very easy one. Now in the C part, it is talking about two different things. First, we need to evaluate what is f of minus 1. We have to multiply with the minus 2, and then we have to add it to the f of minus 2. So let's do it collectively. F of minus 1 means substitute minus 1 in place of this. This is the thing. Plus f of minus 2. F of minus 2 means substitute x is negative 2. Now just evaluate. Negative 3 plus 2. And it is negative 6 plus 2. Negative 3 plus 2 is negative 1. And this is going to be negative 4. So this will become 2 plus of minus 4. So 2 minus 4 is minus 2. That's how you can evaluate this thing. And if you look at the last part, the part D, the part D says minus 1 by 2 x plus 1. So here we just have to replace x with the complete minus 1 by 2 x plus 1. So it is 3 times of minus 1 by 2 x plus 1 plus of 2. So if you multiply by 3, so minus 3 by 2x plus 3 plus 2, simplify this thing. So minus 3 by 2x plus 5. This is the final answer for this. So I hope you have understood all the concepts related to the function notation and what is the relation, what is a function, which particular relation is called a function. So if you have any doubt in SAT Maths, you can send your doubt over this WhatsApp number or on this mail ID. Thank you for watching this.